The GitHub key that broke Taiko. Taiko just proved that a single leaked GitHub key can invalidate an entire Layer 2 security model. This morning, the protocol halted block production after an exploiter bypassed its bridge verification to drain approximately $1.7 million from the ERC20 vault on Ethereum. The failure is not just a code bug, it is a direct result of the design choices Taiko made to scale its base rollup. And the vulnerability started with a discrepancy between what Ethereum saw and what the Taiko chain actually did. The forged proof loophole. The attacker exploited a flaw in how the bridge validates source signals to register fake cross-chain messages. Normally, a bridge withdrawal requires a message sent event on the source chain to trigger an asset release on the destination. In this case, the attacker submitted forged proofs that Ethereum accepted as valid, despite no matching event ever occurring on Taiko. This allowed the exploiter to pull USDC, ETH, and Taiko tokens directly from the L1 vault without actually having the assets on the L2. But to understand how a fake proof became a valid proof, we have to look at the shortcut Taiko took with its prover stack. The TEE Shortcut Backfires. Taiko's security relies on its Reiko stack, a multi-prover system that includes Intel SGX enclaves to generate proofs faster and cheaper than pure zero-knowledge math. The root cause appears to be the exposure of the SGX enclave signing key on a public GitHub repository. With that key, the attacker was able to register their own malicious prover and sign state transitions that the system treated as canonical. This effectively turned a theoretically decentralized rollup into a permissioned network where the only thing standing between the bridge and a total drain was a single private key. This failure exposes the dangerous trade-offs inherent in modern rollup design. The real implication. The Taiko exploit reveals that the base rollup narrative is currently functioning on a multi-prover crutch rather than pure decentralized security. While the protocol claims to inherit Ethereum's sequencing and safety, the introduction of TEEs like SGX created a centralized point of failure that the initial design was explicitly built to avoid. By prioritizing cost efficiency and lower latency over the rigorous, permissionless verification of a true zero-knowledge rollup, Taiko essentially traded cryptographic certainty for hardware dependence. This isn't just an operational error, it is a structural warning to the entire L2 ecosystem. We are seeing a trend where protocols use trusted execution environments as a speed run to mainnet viability, often bearing the trade-offs in the technical documentation. If the security of a multi-million-dollar vault rests on the privacy of a single enclave key, the system is no longer a trustless public good, it is a permissioned enclave with an Ethereum interface. The path forward for Taiko hinges on whether they can revert to a pure ZK proving model or if they will double down on hardware-based shortcuts. Watch for the protocol's post-mortem to see if they deprecate the SGX prover entirely or simply attempt to patch an inherently fragile trust model. Subscribe for more.